this video, we will be looking at Pythagorean Theorem. Pythagorean Theorem is used only in right triangles, and it is used to solve for a missing side length. So we do first have to talk a little bit about how to label in a right triangle. So the side that is opposite the right angle is always called the hypotenuse. So if we look at our right angle here, this side here is the hypotenuse, and it will always be labeled with C. It is also the longest side in your triangle. The other two sides are called the legs, and we use A and B to label them. Now here is your Pythagorean theorem. A squared plus B squared equals C squared. So if you take the value of A, raise it to the power of 2, and the value of B, and raise it to the power of 2, it will match the hypotenuse squared. C is always, always, always the hypotenuse. That is very important. So let's go ahead and try this out for a few questions. So first thing, I have this triangle 3, 4, and I'm looking for x. X is the hypotenuse, so I will label it as C. And the way I label A and B really doesn't matter. So I'll start off by writing A squared plus B squared equals C squared, and I'm just going to plug in all of my side lengths. So instead of A, I'll write 3 squared. Instead of B, I'll write 4 squared. C I don't know, but in my triangle it's labeled as X. And now it's just time to clean up. We always do exponents first. So 3 squared just means 3 times 3, which is 9. 4 squared means 4 times 4, which is 16. And then we can add up our side lengths to get 25. And then we're almost there. We've almost solved for x, but there's still that exponent of 2. The opposite operation of exponents of 2, that would be the square rooting. So we're going to square root both sides. The square root of 25 is 5. And I'm just going to add centimeters here because that's how my triangle is labeled. And there we have it. So in this scenario, we were solving for the hypotenuse. If we look to the next one here, x is actually one of the legs of the triangle. 20 is the hypotenuse. So again, it's going to be very important. You label the 20 as C. And then I'll label x as A and 9 as B. And now again, I'll start with my generic A squared plus B squared equals C squared, and let's see what happens when we plug numbers in. So instead of A, I'm going to put x. So now our x is actually on the other side of the equal sign. Instead of B, I'll write 9 squared, and instead of C, I'll write 20 squared. Now you have a few options here. Because we are trying to isolate for x, we can bring the 9 squared to the other side right now, or we can do a little bit of cleaning up with those exponents first. Your choice. I'm just going to clean up my exponents. So 9 squared is 81. 20 squared means 20 times 20, which is 400. And now it looks like a nice linear equation, and all we have to do is bring that 81 to the other side, and don't forget to switch your sign. So x squared equals 400 subtract 81. So there is an extra step compared to the previous example, and we get 319. But our final step is always the same. To get rid of that exponent, we're going to square root both sides. When I square root 319, I don't get a nice whole number, so I do have to show I'm rounding with these squiggly equal signs, and I'll just round to 1 decimal. So it would be 17.9, and then my units for good communication. And there we have it. Okay, let's try another one. So we'll start off by labeling. I label the hypotenuse first, just to be safe. Across from the right angle is the 10, so that's C, and then the way you label A and B doesn't matter. If it helps you to write, the original Pythagorean theorem, definitely do that. You don't need to, but at the beginning it might be helpful. And now I want you to pause the video here, plug in x, 5, and 10 in for A, B, C, and try to follow the steps. We are in this scenario here because the hypotenuse is given to us. And then come back to the video to check your work. All right, so for A, we should have x squared. For B, we should have 5 squared. And for C, we should have 10 squared. Doing a little bit of cleanup work here. 5 squared is 5 times 5, which is 25, and 10 squared is 10 times 10, which is 100. At this point, we need to bring that 25 over to the other side. Do not square root right now. You only square root when the x is isolated. So 100 minus 25 is 75. And then we can square root both sides. And I want you to be careful with your rounding. So if you had written x is approximately 8.6, you have rounded incorrectly. We have 8.66. That second 6 is greater than 5, so we have to round up to 8.7. Oh, and it's actually millimeters in this scenario. So if you got that right, wonderful. If you made a mistake somewhere, make a note of it so that you don't do it for the future. Okay, one more question before we go to a mini application. So let's see. We have 20 as our hypotenuse, so we're actually doing the same thing again. I like labeling x as A if it's a leg, and then the 16 is the B. So once again, pause the video, try it out. If you had made a mistake in the previous one, try to be a little bit more careful to not make it again here. Then come back to check your work. Okay, so A squared would be x squared. B squared would be 16 squared. C squared would be 20 squared. So that should be your setup right now. Time to deal with the exponents. 16 squared, just doing that on your calculator, is 256. 20 squared is 400. And then, back to the repetitive steps. Let's get rid of the constant. We're trying to isolate for x here. It moves over with subtraction. And when we do that, we get 144. And actually 144 is a nice perfect square. So when I square root 144, I get exactly 12 centimeters. So I didn't have to use my squiggly equal sign. So there's our Pythagorean theorem. I am going to add a little application twist here, but the calculations will be the exact same. So what is the size of the TV below? If you know, when you're looking for TVs, the dimension that is given is always the diagonal. So this question is really just asking us for this length here. So I was given a rectangle. When I put that diagonal, I now have a nice right angle, which means I'm solving for C. If you like using X, you can. If you want to keep it as C, it really doesn't matter. Your choice. So the hypotenuse is C, and then I'll just label 36 and 48 as A and B. So A squared plus B squared equals C squared. So in this version, we are solving for the hypotenuse, which means we don't have to worry about isolating for anything. So I want you to pause the video here. You are actually going to be following the setup of the first example we did, and then come back to check your work. All right, so instead of A squared, you should have 36 squared. Instead of B squared, 48 squared. And then instead of C squared, you can leave it at C squared, no problem. Or you can write X squared, whatever makes you happier in the moment. 36 squared is 1,296. 48 squared is 2,304. Make sure in your calculator you are using the exponent button and not the multiplication button accidentally. When we add our numbers, we get 3,600. And then finally, a quick square root, and we actually get a nice number of just 60 inches. And it is a mini application question here, so I am going to write, therefore, the TV is 60 inches. Okay. And one more. What is the shortest distance across the field? The shortest distance is always the diagonal of a rectangle. That is the most direct route from one corner to the other. If you try to go around like this, there's definitely a lot more for you to walk or run or whatever is happening here. So shortest distance is always the diagonal, which once again means we have a nice right angle we're looking for the diagonal, so I'll label that as x. And the diagonal, it is the longest side in the triangle, so it is given C as the notation, and then you can put A and B wherever you'd like. So once again, pause the video, do this question, then come back to check your work. All right, so A squared would be 20 squared. B squared would be 100 squared. C squared is x squared. And now just a little bit of cleaning up. 20 squared, 400. 100 squared is 10,000. And then we can add up our numbers to get 10,400. And then we will square root that. And we get approximately 101, actually we get 101.98. So if I round that to one decimal, it actually would be 102.0 approximately for x. And that was in meters. So therefore, the shortest distance is 102.0 meters. And I know putting the 0.0 might seem a little silly, but I like seeing it if it's telling you to round to one decimal, which is not here, but I'm just saying that for us. You are expected to at least show the 0.0. And that's it for Pythagorean theorem. So the key thing to remember here is make sure you label the hypotenuse correctly, because if you always assume that the side you're looking for is the C value in the formula, you can mess up on probably half of the question. So just be careful about that, and otherwise you're just isolating for your variable.